Good morning and welcome to the final Relatorium seminar for 2025. Our next event will happen, currently is planned for January 16th. And in the meantime, we will be hosting a live session at the Joint Mathematics Meetings in Washington, D.C. In the meantime, I'd like to introduce David Stern, who is our speaker today. David comes to us from the UK, from IDEMS, and I'm sure he'll tell us more about it. So please take it away, David.
Hi, thank you. And it's a real pleasure to be here with this group. And I'm trying to sort of have this talk, very happy to be interrupted and to make this as much of a discussion as possible. I come from a background of mathematics. I was an algebraic geometer a while back, but I immersed myself in working towards social impact in many different ways. And 8 years ago, with a colleague, we set up IDEMS International, which is a not-for-profit social enterprise where a lot of our work builds on using our skills as mathematicians, but as collaborators in transdisciplinary impact projects. I've chosen 3 of these areas that I can talk about as ways to introduce what we do and how the mathematics comes out, or our role as mathematicians is useful and adds value in many different contexts. And how in this work, we actually often come back to, I find, surprisingly theoretical and abstract mathematics. I'm going to talk a little bit about why category theory keeps coming up as a topic that we find underlies a lot of our work. And being an algebraic geometer, I had a background in this beforehand, but I never expected it to be really as applicable as we found it. So I will try and make a little bit of that link. And then I'll finish by sort of discussing some of the ideas of, well, what do we do? We actually have an impact activation postdoctoral fellowship. We've had a number of people who have gone through this, a very high retention rate of people once they've actually been engaged in this process. A large number of them want to stay on and work in this area. And so I'll talk a bit about that, and then how this actually could come into education systems, and really try to have a discussion around thinking about education systems and mathematical science education maybe differently, and just point to at least one example of where innovation is happening in ways that could be quite inspiring. So that's the plan. I'm willing to be interrupted and for people to direct me to say, could you start here? One of the nice things about these Zoom areas is that I can go through this talk any direction that people want. So if there is something which catches your attention and you'd like me to start there, I'm happy to be directed and to make this a discussion. If not, I will just start at the beginning. Yeah.
Right. So people should either raise their hand if you're on the Zoom, or put a comment on the chat or in the live stream, and we'll be monitoring as well too. I'll be interrupting you, David, yourself, and don't worry.
Yeah. If there's no immediate direction, I'll start maybe with the first piece, which is a long-term project that we've had, which actually predates IDEMS itself. This is some work which I was involved in my previous position when I was at Reading University.
Right. In fact, maybe this is a good place to start, and maybe that was what you were thinking. Set it up for us a little bit. I mean, this much of the work that I know you're doing and you're going to talk to us about is in Africa and more broadly or internationally. But how does a mathematician like yourself, let's say 15 years ago or roughly, right, get to be involved in something like this? How did it come about?
Okay, let me start. I'll go even further back than that. I will start then with a little bit of my history. I grew up in Niger in West Africa, and I was very interested in international development, but I was also rather narrowly mathematically minded. And so as a young sort of teenager, I observed that international development was way too hard. And so I took a gap year before going to university and wrote software for banks in London. And then I became a mathematician, spent 10 years sort of becoming a mathematician and algebraic geometer. And after that, I decided to try and get involved in international development. I went between my idea was a 6-month lectureship in Africa and 6-month postdoc in Oxford. And I was going to go backwards and forwards like that while I figured out what I wanted to do. And after the 6 months, it actually ended up being 8 months in Kenya as a local lecturer. I went to my postdoc in Oxford and I thought, what am I doing here? I was actually really useful in Kenya. I love the maths, but it's a hobby. It wasn't work. And so I immersed myself. I spent 6 years as a local lecturer in Kenya, and I got immersed in all sorts of projects. I came out of that most well known as a statistics educator, but I had been managing greenhouse gas projects in chemistry with chemists. I'd been involved in all sorts of different things just by making myself useful, using the skills I had and being open to sort of work with others in their domains. I then went from there to a Pan-African role in Ghana, and then I got a job back at Reading University in the UK, where a lot of my work was still working with research projects across the world, and supporting improved research methods and many other areas where we were essentially contracted to be a component of research projects which supported socially impactful research. And that then led to creation of IDEMS International, this not-for-profit social enterprise that tries to scale that work. And I'm going to talk about 3 projects that we're deeply involved in, which relate a bit to this. And so I will start with what really came from my time. This has now been 12 years I've been involved with this. This started while I was at Reading University. It's funded by the McKnight Foundation out of Minnesota, Minnesota Mining and Milling. This is one of their philanthropic arms, and their international program is called the Global Collaboration for Resilient Food Systems. And it's centered on agroecology. We do a lot of work with the West African region, which I've highlighted here in Niger, Burkina Faso, and Mali. These are some of the most challenging environments on Earth. They're amongst the 10 lowest human development index countries, with Niger often the lowest. And we've been doing this for over a decade. And our role is a very simple one. Our role is there's a portfolio of agroecology research projects, and we are the research method support, offering support from statistical advice, but also report writing. We do mathematical modeling as part of this. We do a whole range of different things depending on what's needed. And we're there to help support the researchers and the research project. I'm going to say a little bit more about Niger. I grew up in Niger, so I really loved going back and being able to work in Niger. It's a very interesting, it's an inspiring country. As I mentioned, this is the, if you look at the graph of since the 1990s to 2002, it's 2022, sorry, it is basically at the bottom of the Human Development Index. It has improved, of course, but it is the bottom country, except a few years when somebody dips below and then comes back up again. It is an incredible country. It's a country where maybe one of the things to sort of bear in mind, people internationally, when they think of Niger, they think of the terrorism, they think, and pretty much every whether it's the US, UK, most European countries, they have it on the red list. This is a country which is deemed dangerous. But this is a part of the world where I learned about what peace really means. And actually, I find it's the most peaceful country that I've ever encountered and ever been When I was growing up there in the 90s, my little sister would walk home alone at night from her friend's house, aged about 7. And this was absolutely expected and normal and, a really very peaceful place. I'm not saying that I'd necessarily recommend and do that now, but it is still somewhere where, as a culture, it is a very welcoming and hospitable culture in ways which I found incredibly inspiring.
I find this comment, David, that you just made about the juxtaposition of official statistics, which have their value undoubtedly, and maybe you'll talk to us about that. Clearly, it's part of your
Yeah.
job, but at the same time, the lived experience, the vast difference between the two, is so eye-opening. We need much more of that. All these places around the world are places where people live and thrive and lead, many of them, happy lives. And instead of pigeonholing them, as you say, this is danger place, avoid, um, let's try to understand also how they're like us, how it's like us, or in some sense, what can we learn from them as well? And I think that's, I'm looking to learn from the experiences you share with us, whether in the classroom or in outside, and how people feel about their education systems, what math might mean to them, for example.
Absolutely. And I think maybe just some of these photos that I'd like to sort of highlight is on the left at the top, this very dry looking cereal is actually millet. And millet is it's the subsistence crop there. It's the main crop which is grown throughout Niger. And there's of course other crops, but it is the main crop. And you grow it in, as you can see, it's rather sandy. Actually, it's grown in soils which are over 95% sand in certain cases, basically desert-like conditions. You grow it a meter apart. One pocket of millet is a meter apart from the next. And this is where people are, these are the environments that people are actually surviving in, thriving in different ways. It's a very challenging environment. But compared to other environments I've lived in, like Kenya, where anything grows, I was in Western Kenya, and there it's extremely rich in comparison. The soils are rich, the communities are vibrant in ways which are very different. But the farmers were not as knowledgeable. The farmers in Niger are incredible. They have to be so knowledgeable because otherwise you don't survive. I mean, I still remember going to a remote village and being with real experts, international experts. They were millet breeders and other agronomic experts in the car. In fact, they were a minor celebrity in these rural villages because their varieties of millet had been really useful and adopted in the country and very well received. And so I was sort of asking, what is this vegetable which is growing everywhere? And they said, oh, no, that's just a weed. And I said, it can't be a weed. It's everywhere in the village. What is it? And so, well, we'll ask a farmer. And so we asked a farmer and they said, oh, if we do this to it and then that to it and then the other to it, we can then feed it to our animals. And so everything there has a use because they cannot afford not to have something grow and not to be using it. So they're real masters of their environment, and they have to be because it's such a harsh environment. What is our role as mathematicians in this? Well, one of the things that I want to sort of just highlight very briefly here is that when I started just after this farmer federation, which is called Fumagaskia, had been given a research grant. This was a big deal. So the foundation, the McKnight Foundation, has decided that they would give a research grant to the Farmer Federation, where the Farmer Federation wouldn't be the support partner to the researchers, but they would be the lead partner for this research grant. And this was a big deal because when this was sort of discussed with the partners that the Federation would be the leader, the local research organization said, we can't. We are a research organization. They were a farmer federation. If it's a research project, we need to be the lead organization. And if we're not going to be the lead organization, then we will not be involved. And so the Federation said, so the discussions with the Federation proceeded. The Federation was awarded the grant, and the Foundation said, we're very sorry you won't be part of it. A year later, the research organization came back as a partner under the Farmer Federation. And that happened before I got involved. That was 2012, 2013. I got involved in 2014. And they had just done their first year of trials. And it was a 3-year project that they were going to have. And we had the results from the first year, and the results were not scientific. I mean, the experimentation meant that the way they'd done the experimentation meant that they'd included, for example, a little bit of a microdose of chemical fertilizer in their human urine fertilization trial. So they didn't know what was actually causing the positive effects that they were observing. Their design meant that they didn't have scientific proof that what they were claiming, which was human urine, was actually really supportive of these, in this very harsh environment. It was a really useful addition to the fertilization, which everybody could afford. And yet, because of the way they'd designed their trial, we couldn't conclude this. And so my role then was just to come in, offer statistical advice. We simplified the design so that they actually were getting evidence. And the next year they got some inconsistent evidence. So we increased the plot sizes. And the third year of their 3-year grant, they got fantastic results. And those results, and so my role was just helping them to sort of, go through and actually get simple research methods, which researchers generally would have had, but they were doing this at the Farmer Federation. And they were able to, in the third year, get such good results that the head of research, who was a professor at Cornell for the whole program, started getting obsessed by human urine. They called this OGA, which means power. And the human urine trials were so conclusive in this environment. It was astonishing, and it really blew everyone away. In fact, that particular now, the cost of human urine has gone through the roof. This is something where there is now a market where people are selling human urine. If you collect it, then farmers will buy it from you, because it is now really appreciated as a top dress fertilizer. But the real power from their work came because they recognized at the end of that first phase, this was sort of around 2016, they said the real problem we've got is that the researchers we're working with hold the data. And so, we're able to do these trials with them, but it's their data, and, we don't really have control over this. And so my role then became with them to help them interview computer scientists, and they recruited a computer scientist who would build them and enable them to build technology. They have since 2017 been developing an app which enables them to do farmer trials on thousands of farmers. So since 2017, I think 2017 they had 1,700 trials. Not all human urine, some of them were seaborne, which is a way of actually microdosing, let's say, ash as part of maybe a bit of clay to be able to help the seeds get started with fertilization and a different planting technique. It means you can use less seed and make better use of organic fertilizer. And that's been another form of experimentation, which they've shown at scale works interestingly across different contexts. But they're doing this experimentation with thousands of farmers. And this has totally changed power dynamics. Part of my role has sometimes just been to be in the room at the right time, at the right place. I remember one of my favorite examples of this was I was in Maradi at one of the events where they were wanting to do a farmer typology. And they had the social scientists, they had the people from the university there, they had the people from the Farmer Federation there, and I was there in the support role. And this was a project led by the Farmer Federation where they held the funds, they had the control. And at one point, the social scientists were suddenly just talking about amongst themselves, ignoring the Farmer Federation, about the sample size. And, how big a sample do we need? And I looked at the director, a guy called Aminu, the director of the Farmer Federation. And I said in a loud enough voice that everyone could hear, Aminu, are you wanting to do some of your farmers or all of your farmers? And he said, all of our farmers. And so I said, oh, okay, so we're not doing a survey, we're doing a census. And suddenly now the social scientist said, but we don't know how to do that. We always do surveys. And I said, don't worry, that's a statistical problem. We can help you with that. This is not a problem. We know how to do this. And so suddenly that power dynamic changing, and actually it being the federation that holds the power on this, meant that these power dynamics have changed. And my role has often just been sitting in the room as a transdisciplinary scientist, able to understand the different perspectives and build bridges, enabling that power dynamic to change.
It seems to me that, yeah, exactly. Mathematics can play the role of translator almost, or of creating those bridge technologies, um, to enable the conversation, between people who otherwise would not really think they are mutually comprehensible.
Absolutely. And to be able to understand, and a lot of my work has been to sit and to listen and to be in spaces where I'm not an expert, but to learn the language and to be able to translate from one language to another, to be able to ask the sampling question of the Farmer Federation in a way that they understand and they can engage, so that they can have a say and their voice can be heard as part of a transdisciplinary discussion where there are experts who are used to having and have relatively embedded methods. What's so interesting, and the reason I'm really happy to have started with this example, is actually, once you're doing research, and they've now, let me just put this into perspective, they've now got to the stage where the research is no longer funded by the project. The project still exists. It's now gone through 4 phases and it still exists and it's happening. But the farmer experimentation has been institutionalized. It's now something which the Federation does. And the data that comes out of that is there primarily to serve the farmers and the Federation itself. But it's an incredible resource which researchers can engage with, and it changes how you do the research. Because in this context, and in many of these contexts, normally as a researcher coming into a community, the first thing you do is a baseline survey. But you don't need to do that because that data already exists with the Farmer Federation. They already know they have that data on their farmers, and they have that data historically. So you have a baseline and you can have an end line in ways which are natural without this being something which is done specially. It's just part of the data collection processes which exist. This is actually fundamentally changing research paradigms. It's one of the ways I like to think of this. It's a move from statistical thinking of scarcity to forms of data science thinking where you have data abundance. And this is a really interesting element that actually this needs different methods. Your statistical approaches are designed in context of data scarcity. But here's a wonderful instance where they have built structures, human structures, to be in data abundance. And therefore, what they're doing would be termed data science. But it's not the data science of big tech. It's a data science which is different. And so this needs innovation, this needs research. And people are not necessarily working on this. So part of our role is then to translate this into, well, what are the questions that are coming out? How do we need to think of research differently in some of these contexts? And
So,
yeah,
David, let me ask this question. So it seems to me that part of the role now that you're describing, you recognize that you were playing is as a sort of a almost like a systems scientist, right? Like looking at the systems that were emerging, but it wasn't by design, right? It was kind of like you were recognizing them as they were happening. And so, I mean, you repeatedly said you were at the right place at the right time to bring this to the foreground. But it also seems to me that if you weren't there, people would not recognize these opportunities that arise, the shift in perspective that you mentioned. So we often, tend to think of these systems arising, deliberately, or,
absolutely.
but I think that, am I right in sensing that there's an element of almost like innovation, or rather improvisation almost, that again, because you were the mathematician with the right mindset in mind, you were able to call it call it forward and sort of bring the right terminology, the right framework to what was happening, so that
I mean,
it could like benefit from the infrastructure.
yeah, and this happened in very small ways where sometimes it was simple statistical knowledge. I mean, the first example I gave was, their initial results, they would not have got a renewal of their grant because the results they had wouldn't have convinced anyone. And so they weren't scientific. So just the first thing was actually enabling them to understand how simple scientific method, statistical design could help them get better results. That was the very initial point, and that was relatively straightforward and simple. What this has evolved into and what's emerged on this is that actually, I believe elements of how they're doing research are at the forefront of research I've seen anywhere, because they've put in place systems which are different in how they've embedded in social structures. So there was, as you say, this isn't a designed research. It's a federation which is set up to be able to serve farmers, develop things for them. And this is now changing the power dynamics because the federation holds the research grant, not the researchers. And the researchers are brought in because they add value. So the power dynamics have changed. So this is actually looking at very different power dynamics coming in terms of how this works. And that has led to innovations, which I've seen, and I look around and I present this in certain other contexts, and I'm not seeing these innovations happening because a lot of the power dynamics relate to the funding and how the funding's given and who it's given to.
Oh, this is what I had in mind. I'm so glad you brought it up. In other words, who is in the driver's seat, and serves to kind of determine the motivational structures that underlie what's going on. I mean, let's just to oversimplify. Much research might happen primarily with the motivation to publish, or the circular motivation to get more grant money, for what it is that you're doing. So it becomes a little bit of a self-fulfilling prophecy. Whereas here, the research, at least that you're describing, is aimed to serve a particular purpose, and so it's driven much more by the stakeholders rather than the process itself.
And this is, I need to give credit to McKnight and the way that they've set up this program. This is a very deliberate effort of the program. And our role, we are grantees with exactly this role to serve as this intermediary phase and enable this as enablers. This is an extremely privileged and rare role. I don't get this role very often. So again, that idea that actually they brought us in that role to do this, it was again different and part of what's enabled this to happen and these innovations to emerge. But it does lead to models of research, which I've not seen and I don't see talked about enough, that are emerging. These are not established yet because these are relatively small projects at this point, but they're starting to get results and actually get attention in ways which I think are quite exciting. So this is one, and in terms of my personal learning, I've had other projects, and the project I'll go to next is led by a group at Oxford University, and I am constantly taking learnings out of this project and feeding them into my discussions on, in research and how research needs to happen in different contexts. One of the roles that we as mathematicians have and the skills we have is that of abstraction, being able to understand how the same ideas translate from one topic and one domain to another. So the domains we work in are very different. Using human urine to improve agriculture in a very remote area is very different from reducing violence against children, which is the topic I'm now going to move on to, unless people would like to take me somewhere else.
No, I'm just going to plant a seed here. I'm very happy to let you go where you want at this point, but the seed is I'd love at some point to return to what lessons to speculating, about what lessons we might learn for practices that are closer to our experience, for example, academic practices or kind of other political and social processes that trouble us or we're immersed in our day-to-day lives. What lessons can we learn? How can we incorporate these novel ideas? What would it look like in our setting? But you can return to
I'm
it.
happy to jump to that if you would like, or I've got two more instances that I could go into to give a bit more, to flesh out a bit more. Let me go into at least the parenting one, because the parenting one is interesting. They needed research method support. They needed help because they were doing a lot of, actually, I don't know if the name Esther Duflo means anything to people in this community, but she won the Nobel Prize in economics because of her work bringing randomized control trials and methods from the medical domain into international development as a sort of method to try and develop evidence and rigorous evidence for social I guess really social programs, sort of, if you were to spend your money in this way or that way, if you do a randomized controlled trial, can you show that one is more effective than the other at specific impact? And that is what we were brought in to do here. And we weren't the people offering research method support here. This is something we could have done, but there was somebody else who already they had a statistician who had been at Oxford with them and doing that, and they didn't have a need there. But they did have a need for technology to be built in ways which enabled them to digitize their programs to be able to get them out at scale. And so that's the role that we slotted into. And we've been working on this since 2019. 6 years that we've been on this journey with them. And we started where, right at the beginning, they were saying, should we build an app or should we build a chatbot? This was started the questions that we had right at the beginning. And in the end, we had a workshop at early 2020, just before COVID. And we then decided we'd build an app, and that's Parent App. And then COVID hit, and there were a number of the UNICEF offices they were working with in COVID who were sort of already using chatbots in different ways, who said, you should really build a chatbot. So we built a chatbot with them as well. And so we actually ended up both supporting them to build both an app and a chatbot. So with the app, we've gone through a very rigorous process, this randomized control trial on RCT. And we developed an app, we piloted it, we did an optimization study, and we then did an RCT. And the results of the RCT have just come, the publication has just gone into Lancet, and it's hopefully going to come out within the next few months. And the results are mind-blowing. I mean, just one of the flagship results is, I believe, sexual violence against young girls is reduced by 40% by this parenting program using an app. And broadly,
For everybody's benefit, RCT is randomized clinical trial. Is that right?
Yeah, RCT is a randomized control trial. And this is, as I mentioned, this is what, Esther Duflo won the Nobel Economics Prize for this, the Nobel Prize in Economics for this, or for moving randomized control trials into elements of international development. And so
I have a question from the chat that relates, maybe it's appropriate here as well. But Rashid asks, what did you learn from the other researchers? I think he's referring mainly to the previous example that you gave, but who had a different educational upbringing other than yours as a mathematician. So in other words, you were interacting with the other researchers and you were acting as a bridge, between the Farmer Association, the previous one, or maybe something similar here. What was that interaction like? I mean, just to build on this question, how did they understand?
Well, this is what has been really fascinating. As I say, the other work there, I've been involved for a decade. We're still involved. We are continuing to build these. One of the deep learnings that I've had over the years on this is, and I will come back to this. It's the simple fact that I have so much respect for particularly for the academics working in these extremely challenging environments, um, um, who are highly constrained, and one of the things that I learned from them is that actually, we often feel, actually in some ways, those constraints are freeing because, if you don't have any opportunities to get funding, you don't waste your time applying for grants all the time. Because there is no, you don't have access to this. You just get on and you do the work. And they often do a lot with very little. And, they actually spend a huge amount. And what we can often do is actually we just did this very recently. There was a funder, the 11th hour, had this interesting funding approach. And so we engaged in this funding approach, and we managed to get actually two small grants where when it's not grants for us, it's grants which mean there are little bits of money which are now able to enable them to get students to work with them. There's this amazing grant which goes across Niger, Burkina Faso, Mali, and does biological control of pests. And it does all sorts of other things now. But the amazing thing about this is the pyramid of students that they've got. How they're able to use a really small amount of money to just sort of, create this whole infrastructure where there was just one entomologist working in this whole area. And now they've actually trained a whole generation of people, who are now filling out the other universities. There's been an explosion of local universities, so they're getting employed by different universities, but they have a research group and culture which is unrivaled, with structures in place to be able to do capacity building in ways that I find inspiring. So one of the things that I've learned a lot about is that actually we think of grants and the processes around these as being enabling, but what actually happens is, we only do the things that we can get a grant for. Whereas actually my collaborators who are working in these more constrained environments, they do the things that they think are needed. They do what they need, what needs to be done, not what they can get funded. And it really is a really powerful difference.
Absolutely, David. I'm so glad you brought this up. I know your friend has something to say, I think, about it as well. I wouldn't be surprised. But just to foreground, to repeat again and make it more, more obvious, perhaps, that what you're saying is, again, to flip the narrative, and you're not doing the thing because you have the grant. You're doing the thing because you want to do it, because you think it's important. And then you seek grants in order to engage more people, in order to scale, in order, to involve, to become more inclusive. So your job isn't justified because of the grant. I mean, it's such a mindset shift. Irfan, sorry, go ahead.
Yeah, I mean, I definitely would have a lot to say about that, but that's not my question right now. I had a different question actually about this app. Because you mentioned that sexual violence against girls had decreased by 40%. You might have explained what the app actually does, but once you said that, I started paying attention very intently and I was probably distracted. So could you explain again how it achieved that?
Yeah. Okay. Sorry. So let me just take a step back of this, and let me now move back from the ecology example to now the parenting one. So the group we're working with here is actually it's been, again, they've been at it for 15 years or more, where they've been developing open source, open educational resources for parenting programs. They actually had done a whole set of randomized controlled trials based on these face-to-face parenting programs. In the UK, we have NCT classes before you become a parent. They prepare you and they go through. So they were doing this in low resource environments all over the world. They had trials which these were impactful and really had positive impact on a whole range of indicators, from reduction of violence against children to actually mental health outcomes and all sorts of other things. And so they had this strong body of evidence which related to these face-to-face programs. The problem was they couldn't scale them because they were too expensive. It ended up being over $100 a family. if you wanted to implement this. And in the sort of low resource environments or many places they were working, this was just unaffordable to do at scale. And so they approached us for various reasons to sort of try and innovate with them. Well, could we turn these face-to-face programs into digital programs and actually have some impact through a more scalable digital program? And that's where they were doing this through chatbot or through apps. And there were advantages and disadvantages to both of these. And we originally decided with them that the app was the right way to do this. And then, as I said, there was a number of opportunities to build chatbots. And so we built chatbots as well. And these are not your AI chatbots. These are deterministic chatbots. There is interest in AI coming in, and I could speak to that afterwards. But one of the things which is so important is that if you have AI involved, then you are not absolutely certain of what information is being communicated. Whereas if you have a deterministic chatbot, then you can control the information that's actually going out and the advice which is given. And so as I said, the app started, and the results from this are just phenomenal. Just to put it in perspective, in the latest study, the results are equivalent pretty much to what was happening on the face-to-face program. And the cost at implementing this at scale is potentially as low as $6 per family. So it is a reduction in cost, which is just immense. And $6 a family, now we have national governments all over the world that are interested in this. And so they've actually got now a scaling plan, which is going out over the next sort of 3 to 10 years, where there are many countries that are looking to implement these programs at scale as part of their their sort of health services in different ways, and health and social services. But the interesting thing here was our role again as mathematicians doing this. If we'd just been software developers, we'd have had a particular lane we were in. We either developed apps or we developed chatbots or we do whatever. And they come to us and then we just do what we're told. We're not very good at doing what we're told. We tend to interact and be part of the discussion of this. One of the characteristics in both of these cases is we're part of the leadership team of the whole project. As academics, my role is to engage in the intellectual thinking as well as the implementation of the technology in this case. And that was really important in this context because actually what parent text did was very different. They didn't start with the randomized control trial. They started because they had many countries that were interested in trying to deploy something very quickly because of COVID. And so, they started with implementation, in the Philippines, in Malaysia, in South Africa, in Jamaica. They then had Parent Text 2.0 in Malaysia, South Africa, China, Mexico. And we were the only people, in their whole team. This was a big program, but their teams didn't actually interact on the deployment, on what was happening, because as research projects happened, well, these are separate projects. They had separate funding. They had separate, management structures. They had separate academics who were responsible for them. And so their teams were almost totally disjoint, but they were working on digitizing the same resources. And we were the glue who was tying them together because, as our role was to help support the implementation of both. And so what we were able to do is feed back the learning from one to the other and actually cut across the differences of the fact that one of them were building chatbots, the other team was building apps. But there were many of the things that they were trying to do where they were asking the same questions, where they should have that learning. And even though they were part of the same bigger team, they often didn't have the connection at the detailed level to know what learning to go back and forwards with. And so a lot of our role ended up being sort of creating some of those links.
Can you tell us a bit more about how you did that? Like what paradigms, what modeling frameworks or digital infrastructures you provided? How did that work out? Because that's a bigger problem. I can see that being a problem even in the developed world in terms of
no, absolutely.
We often seem to be replicating the wheel, between research grants
Exactly.
and this sort of
Everybody's
initiative.
reinventing the wheel all the time. It's crazy. It's crazily inefficient. A lot of the research that we're doing in many different ways is very inefficient because there aren't the joining people, because everybody's so specialist. It's, our role in this has not been to be a specialist. This is the value of the really educated generalist. We are people who are then cutting across, and we actually play a role of, well, okay, you need support on this, you need support on that. Well, okay, we have enough expertise to help you.
I'd like to try to take a stab to see if that's along the right lines, which is
Yeah.
whether, the question that you were trying to get at is how to make the naming of the component boxes that are being created dependent on the ways in which they're being used or how they interact with the other groups, as opposed to how the originator saw them, the function that the originator saw them.
Yeah. So let me try and take what you're saying and just reformulate that slightly. Rather than naming its ownership, the key question is about ownership. Who takes ownership for what? Who has the decision-making power on what? Can we separate out? At the moment, a lot of this is defined by the developers, but actually the decision-making power is critical. So who takes ownership for what? That's what you're really wanting to do. Ownership should not be defined as the start, because ownership should evolve over time, and ownership needs to be dependent on context. So a lot of this is about being able to have communities take ownership. Now, this isn't possible if you take a commercial model, but a lot of people are already working in the open space. And if you have open technologies and you're wanting communities to engage with them in different ways, then really this leads to possibilities or different possibilities of ownership that could change and evolve over time. In ways which actually could be very powerful, overlapping ownership in different ways, that ownership at different levels of different parts of a bigger whole. So, and yes, so broadly, you're absolutely right. It's that fact that ownership is not something which you can define at the beginning, because it might evolve over time. If you're an organization and you employ a computer scientist like the Pharma Federation did, you might be able to take ownership for quite a lot. But then if he leaves, your ownership, what you actually want ownership of, because what you have the skills to manage, might change. And so you need to be able to have that flexibility of what you're taking responsibility for, what others are taking responsibility for, as part of a collaboration. So this idea of actually having different communities, having different ownership within a coherent whole, is a really hard problem. And it really corresponds to parenting for respectability. A whole nother parenting program took up the same infrastructure and started building within that as well. There was a facilitator app that got built for facilitating the facilitator, or for enabling the facilitators of the chatbot to be able to manage their chat groups. There were, and then the chatbot itself had a new version of the chatbot for countries in crisis. They called crisis text. And then there was, so where am I? Sorry, I've got, the next thing should be that the parent app, actually, there was a new version of the parent app that started getting built for a different age group. And that actually built from context and content that was already in parent text. And so in the chatbot. And then you actually had the RCT, the randomized controlled trial of the parent text. Actually, that was really fun. This is one of the few cases where they opened this up and too many people signed up too quickly, crashed the whole system. We managed to fix that, but they ended up extending this they were aiming for 15,000. They eventually cut it off at 23,000 people on this RCT, on this randomized controlled trial in South Africa. And the fascinating thing was that as part of how that happened, what was really interesting is that we had taken innovations and learning from what we did in Parent App, and we'd brought them in to be able to say, well, what is it that we could do to enable people to sort of do, and this was a really low cost randomized control trial. The randomized control trial for Parent App, there was huge amounts of funding that went into it. But we took the learnings from that, fed that back into the parent text, and were able to do an extremely low cost, highly successful, large scale randomized control trial because of the learnings we'd had from the app. And the interplay of learnings was so important there. I could go on forever about that. I'm going to just say two things about the climate work, which I think are really important. So there's a whole other set of project, another project we're part of, Participatory Integrated Climate Services for Agriculture, PICSA, not Pixar that makes cartoons. They've been they started off quite small, but they've now got quite a number of countries where they've been out. They've got quite large numbers of people engaging in using this approach, which has shown to, and actually I believe this is a little bit out of date because I know there's work in Tajikistan going on now. There's a whole set of other countries, so this must be a couple of years out of date, this map, sorry. But they've, one of the things which has happened here, which is so interesting, is that the way this has scaled, again, similar to the parenting approach, this started with a process of training extension officers, working with the Met offices to produce the products which could be used as part of the climate services. And then they needed to get to scale, they needed to engage in building apps which support this. And what is really hard to scale. One of the things, they've got a whole process. And if you look at all the different things that they do in their activity as part of this, actually, our role has often been to remove the barriers. And actually, every other piece of work we're involved in, we understand how if we were to really remove all the barriers for scaling for this one project, we would need to use all of them. There was an element where the Met offices actually need the chatbots to be able to improve how they get the data into their systems so they can provide the data to the farmers. There are ways in which actually the farmers themselves, they need the app and they need apps to be able to do this. There's then the research methods. Actually, if the farmers were doing farmer experimentation of this and getting those results, then the things that we're doing in the West African context with these farmer experimentation and that new paradigms of research would really enhance what's happening here. What's fascinating is even without that formalized research process here, over 90% of farmers report changes to their agricultural practice based on going through this process, which then lead to improvements in their livelihood. Because my favorite instance of this when I was in Kenya, actually, I was with a group there of farmers who were looking at the data. And they said, but why is there no trend to the rainfall? They had been told everyone knows about climate change. And they were saying that, their yield has been going down for the last 15, 20 years. It's been consistent. So it's rain-fed agriculture. So if the yield's been going down, that's because there's been less and less rain. But there isn't a trend in rainfall. And so they just started discussing, well, what if it isn't the rainfall which is going down? Well, what's happened? Well, actually, what happened was 15 years ago, the fertilizer subsidy stopped. And so people stopped using sort of fertilizers in the same way. And so the problem wasn't actually a climate change. It was soil fertility change. And soil fertility, you can do something about that. That's why these methods are so empowering to see the farmers suddenly realize this wasn't this anomalous, climate change is the problem, which they'd associated. And when you ask them, that's what they'd associated things with because they'd heard all about it. But to the recognition that actually, there might be climate change issues, but they're not our problem. Our problem is soil fertility. And soil fertility is something we can do something about. And so that was so empowering, and to see people empowered by the right information in the right way is incredible. But to get these approaches out at scale, there are just so many barriers. It's just really hard, and so many different things are needed. That's why we need these sort of generalists rather than just specialists. I'll very quickly go through these bits, but I'd be keen for this to be more of a discussion. So one of the things which I think is so important, I've taken 3 of our pieces of work. We have more. But in each of these, there are similar underlying problems. Very often, it relates to the fact in each of these three contexts, we have international researchers working with national partners, working with local implementers, in these highly complex collaborative contexts. No one holds all the information. There's always this complex set of collaborations. And our role and where we've been able to add value has often been to be able to translate between the needs of different actors, understanding multiple perspectives and enabling this transdisciplinary element. And very often, the issues that we're solving are enabling collaboration. And so this is where I'm going to make that link back to category theory. We find in almost all of these cases, when we start digging deep, and it is because within our team, we have a number of people who were, as mathematicians, very comfortable working in, with category theory, understanding how this bridges across mathematics in different ways. And we find categorical thinking really useful, and it actually comes up a lot. And we've engaged with partners, and some of you might know the Topos Institute, and so we've engaged with partners like that and actually saying, well, can we formalize this? We have not yet had any value come from that formalization process. We have had some bits coming in which are there, but the formalization has not yet been able to help us solve the issues that we have, the concrete issues that we have, which we're going to the mathematics for. And this is where there's a really interesting tension of sort of, as soon as it becomes research mathematics, there's a particular approach, a particular formalizations, which then align with journals, which align with specific needs in terms of our academic structures, which may or may not relate to the mathematics which is emerging. From our perspective, if we were just, I don't believe this is the case, because actually we've got some really good people on the team, and I myself was deeply involved in some of this work in the past. And so if it is just that the knowledge is already out there and we just need to apply the mathematics, great. We don't need new mathematics. But what we're finding is we don't have the tools don't exist yet. And yet we're struggling to get it so that we can actually get the maths research to enable and really engage with the problems that we need to solve. And that bridge is a really hard one to cross. So part of my hope in engaging in this community is to sort of have those discussions about actually building some of these bridges back in from application to, and I don't mean applied mathematics, I mean real concrete applications where we are coming across challenges that I think could be solved by mathematics or need mathematical advances to solve. And that's part of why I'm here.
Well, David, this is a perfect place to land this. And I'd love to open the conversation. I mean, this is exactly what we're after, at least aspirationally. That's what we hope to accomplish. To put yet another spin to this is, how can we learn as mathematicians to change our own perception of mathematics, our very practices, in order to facilitate that from the experiences you're giving us. In other words, it's a feedback loop, right? But being mathematicians who foreground wanting to make an impact in the world, we're seeing our own mathematics, the creativity that you're calling for, as as needing to basically, we have to reinvent how we construe mathematics. And because too much of that perhaps was left to basically be driven by processes that were out of our control. For example, commercial publishing and grants and all of that, that arguably, I'm not trying to make the decision, but I'm stating a case that should be very seriously debated, that arguably it may not serve mathematics the way that that was intended. And so it's a sort of crisis of foundations of a different kind. Not only the foundations of the formalizing, but the foundations of why we're doing what we're doing and what motivates us. And so thank you for showing us a different aspect of the mathematical universe that I don't think we get typically exposed to. I wonder if I believe people would have comments. So at this point, any comments are welcome.
So I really like your term, really educated generalists. And I was wondering if you had anything to say about how could we, as a society, facilitate more really educated generalists? Because my understanding is that in the past, that was the norm. Any academic was to some extent generalist if you go back like 200, 300 years ago. But now we are also hyper specialized, and if we want to become generalist, we face a lot of obstacles.
Absolutely. Our academic systems are broadly constructed around specialism. So there's if we want to take this at a large academic sort of institutional level, it's really hard. And I've had this with universities in general. There's a lot of people who recognize the importance of transdisciplinarity, but actually in the UK, and I'm sure other places are very similar, your whole research excellence framework is built up around specialisms. So, if you're a generalist and you don't live in a specialism, if you live in a specialism, you're allowed to go out and do other things. In fact, that's encouraged. But you've got to know where you live as a specialist within our academic systems. And so I think one of the things to think is, well, how do we create space to value elements of this, of being a generalist, of doing that? And this is the phrase that we've coined on this for mathematics is impact activation. And just very concretely, we have an impact activation fellowship, which we do for postdocs. And the first thing we do in an impact activation fellowship is give people work which has nothing to do with their specialism. Actually put them in somewhere where they're totally outside of their comfort zone. Where I had so our app work was the mathematician involved in that was a topologist, and she got involved in app development. The person who got involved in the chatbot work, she's an applied mathematician and modeler, nothing to do with that. The person who's got involved in our mathematical modeling was a pure mathematician, sort of algebraic geometer, I believe, and so on. So whatever specialism you come from, your first task will never be related to your specialism. And that's one of the first steps that we do with at the postdoc level. I think there's things we can do at other levels, but at the postdoc level, that's one of the first things that you do, that you're put into a room in a context where you are no longer an expert, and you're told to listen and to observe and to see. And this is the collaborative service approach. The bar is to simply add value. If you can add value, you've done your job at the beginning. That's all you need to do. You need to add value in whatever way it is.
So
it seems to me. Go ahead. Sorry.
Sorry. Yeah. I'm sure I can look this up, but I was wondering, are there any requirements in the impact activation fellowship, like your PhD needs to have been within last 3 years or 5 years or something like that? Because there might be a lot of PhD holder mathematicians who might be doing other things, who might want to come back and do a postdoc on something like this.
So a really good question. We've at the moment, we're actually looking for funding to be able, with the Topos Institute, to scale this to cohorts. But at the moment, it's been very much individual, project by project. We sort of take individuals in, and so it's been individual recruitment processes. And so each recruitment process is individual. There have never been requirements like that. We actually gave a workshop on impact activation fellowship, impact activation workshop in Edinburgh as part of ICMS last year, earlier this year. It was earlier this year, and so we've started to think about how we systematize that. We actually found that 1 week workshop, we didn't have the pathways to actually make it what we felt was useful. So we feel that's not enough. That's where we're now thinking we're more interested in a cohort approach. So this is something which is still evolving. We've done this. We've had about 10 people go through this over the last 5 years. But it's an emerging process for us. We're learning as we're going. But there is no limitation on that. And we have had people with more experience interested in the process.
I was going to ask a different question, well, related to this, but
Yeah.
you and I have had some conversations around this as well. I wonder what difference do you think this experience could potentially make, or maybe should make, in the classroom, in the way we prepare mathematicians, or we prepare more broadly, informed citizens about mathematics? What role should mathematics play, given the fact that we have this amazing resource, right? Like, we have access to essentially every young person on the planet for 12 years, or a number of years of their formative years. What difference can we as mathematicians make to facilitate this?
But one of the things, and I mentioned, I got very involved in the statistics education community. And one of the things that I firmly believe is that in maths education, one of the challenges we have is that the sort of competitive nature of mathematics education is it's sort of like a moving train. If you step off at any point, you get left behind, and it's sort of, we leave a lot of people behind as we go through the standard maths education. People just getting left behind, left, right, and center. You then get a very small number of people who are very good at mathematics, and a lot of people who hate it. And that approach to mathematics, I think it has been successful at getting people who are very good at mathematics and training good mathematicians. So I'm not saying that this is, I'm not saying this has been a bad approach. On the contrary, it has been almost, any of us who have gone through this and become mathematicians, it worked for us. But is it the best approach to teach mathematics at scale within society? And if not, what are the other approaches? And I don't know if people are familiar, but it's over a decade ago that Conrad Wolfram had this computer-based maths as a sort of something that was trying to think about how you do mathematics differently. One of his claims was that with technology, there's a possibility to make mathematics both more conceptual and more practical at the same time. And that could really change how we think of and how we do mathematics right through education. And that's a really unique opportunity. Normally, you're compromising. Either you're making it more conceptual or you're making it more practical. But using technology, there's the potential to do that. And so I engaged over a decade ago with this, and it didn't go anywhere. And I think I have some insights as to why it didn't go anywhere, in my opinion. But I think that fundamental point that there is an opportunity to make mathematics both more practical and more conceptual in the way we teach it at young ages, I really believe in. I still buy into that. And my hypothesis is that if we didn't think of it as being mathematics education, but we really sort of leaned into mathematical sciences education, where we thought of, if you want, data skills, mathematical abstraction, and coding as being sort of equal partners from the first year of primary right the way through schooling, and actually motivating, rather than many people, I still remember my father's era as a statistician, mathematics was the prerequisite you needed to get into statistics. And then since then, people have often now said, well, with data science, you've got to learn to code before you can do data science and analyze and interact with data. I don't believe that. I don't believe either of those. I think that actually, if you think about data skills and investigations with data and working with data, and you think about mathematics and the power of abstraction, and you think about coding and the ability to sort of code things and do things, these three together can complement one another. They can support and they can engage if they're put on an equal footing. So one of the big hypotheses is that we could transform education and mathematical education by rethinking it from the ground up. And there is a group that have started this since 1992. They had a curriculum reform in 92 and another one in 2007, where they put statistics and data thinking from the first year of primary school alongside more traditional mathematics. Now, there have been challenges, but there's really interesting learning which is coming out of what they're doing. I'm not saying they've got things right and people should copy, but I am saying there's interesting innovation which I think we should be learning from. New Zealand is really interesting in terms of what's coming out of that. This is now a 30-year experiment which has been going on, and very interesting insights coming out. So yeah, those are some of the thoughts on the education side.
Thank you. Yeah, I mean, I do get troubled with sometimes what to me feels very much like a reinforcement of the siloing, against which we rail often. I mean, there's no dearth of mathematicians who complain about, older ones like me or even older than me who remember maybe vaguely an earlier era where they could. I mentioned the JMM earlier, where they could walk essentially into any of the JMM, plenary talks at least, and understand what's going on and feel involved and engaged. Certainly that was the case a couple of generations ago when my father was a mathematician, was being trained. It certainly is no longer the case. Not only is it not the case, it's not encouraged. It's not seen as necessary. We complain pro forma about it, but, and then even more so with other disciplines, and that I think that belies the actual, formative mathematical experience. I mean, I don't mean just individually, but as a discipline, it arose very much in interaction with other fields. As I know my friend Matt here will attest. I mean, we often describe, he works in non-standard analysis, and a story he often likes to share is how Abraham Robinson, who started non-standard analysis, began his work during World War II as an engineer, basically working, with the RAF. So, obviously we don't. I mean, there's so many examples of this sort of thing. Von Neumann, let's say, or there's many examples. So it is to some degree. So I'm pushing back a little bit on your earlier statement about that how the system has been successful. I think it's been successful essentially in a circular way. We can define ourselves to be successful at the thing we're doing just because we're doing it. It's almost like we've been changing the goalpost, or we've created such strongly reinforcing feedback loops that basically make anyone who doesn't feel like they're being successful leave. And of course, society at large. This is not just the role or the responsibility of mathematicians, but society at large has made it feel so prohibitive to not engage with something that you're being told is successful, or the sort of the success story, the single story of success is very damaging to maintaining and cultivating a diversity of perspectives that it seems you're advocating for. And I would agree that's the lifeblood of innovation. Without that, you don't really get new ideas.
Well, and just from a personal experience, once I committed in Kenya to this broader view, I had a decision. Did I carry on as an algebraic geometer, or, and I would have had to give up on the other things I was doing to do that. I couldn't do it on the side. There was no way to stay engaged in the work that I enjoyed. I loved it. I loved tilting T structures on, it was great. I had great fun with it, but it was something which I couldn't continue to do without being immersed in that environment. And that's this is also something which is, well, what other environments could we create which would actually be more inclusive in certain ways? Those are interesting questions.
I know that Irfan has. Yeah, I know. Matt, would you like to?
So my background started in chemical engineering. So, but I guess at the beginning, when I went to conferences, I did feel like I could not I often went to talks that I could not understand at all.
Mm.
But over time, I've put a lot of time into learning other areas that I don't work in. I enjoy doing that, but I don't think everyone does. And I think there's room for both the, as you called them, educated or very educated generalists and the specialists. But I don't think everyone agrees that there's room for both, and that's part of the problem. And that's, see, the origin historically of pretty much all academic work and research related work was in philosophy, which is a very educated generalist position. Everyone was a philosopher. Everyone that did what we call mathematics now, or physics, or science, or letters, or humanities, every bit of it was developed by people who were just called thinkers or philosophers.
Why we have PhDs.
That's exactly right. That's the origin of the reason that we get degrees called Doctor of Philosophy. But part of the reason we have a degree called Doctor of Philosophy is that we have built the credentials to also be specifically trained enough in a particular area to help define the future of that area. Society has developed this degree as a way to recognize our place in that role. And yet that doesn't mean we are the exclusive holders of that role, because other people develop the skills to be able to help us do that from other perspectives, other jobs, and things like that. So I'm glad you're bringing this in, and I want to see more of it. It's most of the kind of work you're doing is quite far from anything I've been trained in many ways. But I am convinced that several of the things you've talked about are tangentially related to things I've deeply concerned myself with in the past, in a variety of ways. And I wish I knew more to be able to do the statistics associated with these things, and to interact with these kinds of researchers a little more. I appreciate the talk very much. Yeah.
Thank you. Maybe just the one thing I will just pick out is we actually did some work recently with philosophers on responsible AI. And it is fascinating to see how the discipline of philosophy has evolved. And this is something where that's also something where as specialists now, they have a specialist knowledge and a specialist role in a way that I don't know that I appreciated before having that they have become specialists as well. And it's a very interesting, formulation that, philosophy itself has changed substantially from what it was, and it has itself become a very specialist discipline. But it was really great fun to engage with them and to actually recognize how these discussions across disciplines like that are so valuable and important there. They really changed my thinking a lot about the value and how to think about the need for philosophers as part of a discussion on responsible AI. Anyway, so I really appreciate this sort of the interaction with philosophers and the engagement of philosophy in this is really something which I'd have loved to be part of the days where that was an inherent part of what was expected of a scientist.
Oh yeah, me too.
This is I love this, and I have what to say, but I think this is a great time to stop maybe the live stream. We've gone through, this has been so fascinating that we didn't even realize. So let's stop the live stream at this point. And if you can stay just a few more minutes, we can continue the chat here on Zoom. Thank you, Irfan. So, what I was thinking is perfectly, you perfectly articulated this, what I had